Now, on the second order, DE, we have got actually a statement which can be represented by here double prime plus AX prime plus BX is equal to 0, which is the same as d squared y dx squared, or it can be dt squared plus a bracket dy dx plus b, okay, it can be any value, is equal to 0. So it can be represented in this particular form. So the way we present it is like we have got a quadratic equation. Now when this one this value here is 0, then we call that one as a homogeneous equation. But when this particular value at the end is not equal to 0, then we call this one as non-homogeneous equation. So this is actually how we interpret them. So what happens is that because these ones, they are like quadratic equation, we actually can be able to solve an equation, this one. So we actually like, because this one is squared, is like x dot dot at this particular point. So we actually present it as r, and because the other one is just x, so we actually can be able to present it as ar, and because the other one is just a bx, so we just take out a b as a coefficient of x, and then we actually say is equal to 0. Then we can be able to solve for this particular equation. Now, because it's quadratic, we can actually have like equation 1 is equal to r1 is equal to negative 1 over 2a positive square root of 1 over 4 a squared minus b, and the r2 can be equal to negative half a and the negative square root of 1 over 4 a squared minus b as the solution, which is the same as x is equal to negative b positive negative square root of b squared minus 4ac divided by 2a. Only that we ended up dividing everything by this to actually represent it in this particular form. So it's the same equation that you know. So when we solve, we must be able to establish what could be the value of the equation. Now, so based on the rule of now quadratic function, based on the rule of quadratic function, so we can be able to actually start interpreting things to say sometimes it might occur in a situation where we have got two roots. We have got a quadratic function, and this is a situation where we've got two roots, and we've got another situation where we've got a single root, that is the single solution, and we've got another situation where we don't have a root at all, like this. So when we have got something like that, this one again, we have got some general formula which can be noted. Now the general formula which can be noted in this case can be represented in this form, and we can actually have a general formula like it can be x is equal to a e that is r1 t plus b e and then r2 t. So this is actually the solution, where in this case r1 and 2, okay, r1 and 2 is equal to is derived from negative b positive negative square root of b squared minus 4ac divided by 2a. So it means that whatever solution that we are getting for R1 and R2, we can be able to substitute them in that particular equation to get the value that we need. And if we have got a single root, then the solution become x is equal to bracket a plus b close bracket t, and then e rt, where in this case r is equal to negative half a. So this is actually the solution that we can have. And if x is undefined, then we have got a solution which is x alpha t, like that, bracket a cosine of beta t plus beta sine of beta t. So this is actually the situation where alpha in this case is equal to negative half a, and the beta again is equal to square root of b minus 1 over 4 a squared. So this gives us the issue that we have. So it gives us the issues that we have. So these are the major statements. So this is statement number 1, as general statement number 1. This is statement number 1, and this is the general equation number 2, and this is general equation number 3. So I want you to actually understand how we can apply, because this one, it is applied when this situation is validated, and the second one is when this particular situation is done, and the third one is when this particular situation is done. So we can have different roots representing different statements at that particular moment. So normally when we are solving a problem of this nature, we always have got the longer way of solving these statements, because we must be able now to establish as to what is the relative nature of that statement. And secondly, we must be able to know how the values can be represented in an easier and a more direct manner. Now let's take an example. You can actually have a situation where you have got like x double minus 3x is equal to 0, like this one. So this is I want us to solve this one using the method that we have been given. So it can be the same as r squared minus 3 is equal to 0. So this equation has two roots, because then r squared is equal to 3. So in this case, it implies that r is equal to positive negative square root of 3. So we have got two solutions. So in this case, you can now say x then is equal to a e. Then I will say where there is r1, I'll put negative root 3t, and then I can add plus beta exponential, then I will take r3 and t. So I can actually have this particular statement. So you can actually see now that this can be the general equation. But now this general equation, if you have got an initial condition, maybe given that x0 is equal to 4, then you can actually now substitute, because this is the same as xt is equal to 4. So it means that you can now, if you have been given something like that, you can now start substituting. So you take 4 here, you take 4 there, you take 4, you take this particular 4, you take it and substitute it here, and you take the value of t, whatever is given, you put it there, and you put it there. Then you solve that particular equation. So like for this one, it would have been 4 is equal to a e negative square root of 3 and times 0, because that is 0, plus beta e square root of that one, 3 times 0. And then you solve this one. So in this case, it can be 4 is equal to a, because this one is cancels to become a 1, plus b. So you can take this one. So it means that if you have got another second point, maybe xt, maybe x7 is equal to maybe 10, then you can take these values again and then get another equation, which if you solve for a and b, you can now find the general solution for that when a and b are solved simultaneously. That's the way we actually can be able to solve the problems of that nature. Now, having done that, then you are able now to solve now any value which can be represented to infinity. It can now, you can actually even solve, say, what is now x900? What could be the value? So because you now know this, you now know that, and you can now, now t is now equal to 900, then you can take it into those equations and then you get x at the spot of 900, and then you get the actual value that you need. So that's actually how we actually solve problems of that nature. Okay, now I want you I can write some examples which you can be able to practice in the second order, so that you can actually see how best that can be done. Like the following, you can try out the following to say, okay, I will write it in the next example. Thank you.